Hi, everybody. Wondering why I'm dropping so many frames. Oh, no, it stopped. Must be that opening video. Something up with that opening video now. So, hi. I don't know how many people are going to show up. I haven't streamed in so long. I think everybody's forgotten about me. I have an interesting one. As usual, it's always something different, something weird, something interesting. I'm going to try to explain this. This is new to me, this thing going on here that I see. And amazingly, there's some notes in the schematics that try to explain what the hell I'm seeing here. But I'm going to try to explain it to you because I have never seen anybody explain this. I have never had it explained to me. I had to figure this out myself, and this is a head scratcher. So I don't know what the hell happened here. This is weird. So what I have here is a 2681 MacBook Air. Everybody. So there's a 2681 MacBook Air, and it was not charging the battery. It would turn on, it would work, everything was fine when it would work when you have it plugged in. As soon as you unplug it, instantly off. Not charging the battery, but not running off the battery. Just not turning on the battery. I guess, yeah, back up some. You have multiple levels to battery communication and battery working. You can run off the battery and still not charge the battery. So you can take a charged battery that you've charged, new battery, or if you charge with another logic board and plug it into a logic board, and it will run the logic board, but when you plug in the charger, it doesn't ever put any energy back into the battery. That's a condition. This is a different condition where it would not run off the battery. So you plug it in, you plug in the machine, it turns on, it runs, everything's fine. As soon as you unplug it, it instantly turns off. So it doesn't take any extra power, it doesn't put any power into the battery, but the battery also does not power the system once you lose charger power. So that's two different conditions of error on the battery. Both of them have much different explanations on why they would have went bad. But this one is the latter, where the battery was not working at all. Would not charge the battery, would not run off the battery. So the battery is charged in the system. I found that out with a test logic board. This is a logic board I bought off of eBay that is iCloud locked. Very good to have these laying around. One that you don't take things off of just so that you can test things. So let's take a look at the battery circuit and where I started with this. So where I started looking would be a good logical place to start is the battery connector. This is the new battery connector on the MacBook Airs. It's this little thing, little top connector. I'm not a fan of it. I don't think you should be pushing that much power through these little pins. But engineer-wise, on paper, it's fine. In practice, I doubt it works too well. So this is the connector. So I'm just going to scroll through all the stuff for the battery. This is the battery communication stuff. All this stuff here, you see that I've done a lot of probing on this. A lot of things are smashed down and weird looking because I've been sticking this with multimeters everywhere on all of this. We go a little bit farther down here, and this is the battery charging MOSFET and the current sense resistor for battery charging. Some stuff up underneath this shield, too, that I was taking a good look at. That's why the shield is bent up. And then we come down here to the ISL. The ISL is responsible for the main power rail, which is PP bus A on this board, and the battery charging. And they have two sets of current sense. One's for, I think this side is for the battery charging, and this side is for the system itself, the PP bus A on. So that's one of the first things that I thought of when you come to this condition is something wrong with current sensing. And if you can't current sense what's coming in or going out of the battery, then this thing's just not going to let the battery power anything. So I checked all of that. Everything's fine with all the current sense. You should have about 3 ohms of resistance across. So let's show you this on the schematic. We'll switch over to Paul Daniels' lovely software. This is Flexboard View, an old version. I'm sure if he sees this video, he will yell at me that I have not updated my version yet. So we're over here on the ISL, and we have the current sense resistors here. So let's go to the PDF. So here's your current sense. So this box right here, I need to see a preview and see if you're even seeing my mouse pointer. I have not set this up in a while. You'll have to excuse any errors. Are you seeing my mouse pointer? Yes, you are. Okay, good. So this is the ISL. This is that box that we were looking at with all the little solder balls underneath it. And then we come over here. This is the battery current sense. So yeah, I was on the correct side for the battery current sense. So this is to from battery. This is the line that's coming from the battery, comes in through a MOSFET to control battery coming in and out, charging it or powering the system. And then we current sense that with this is where the charger is coming from. So this is the power input that's coming from the charger through this giant MOSFET. It's total maze of connections and everything here, kind of hard to follow. But you're coming in through this MOSFET, and then it's coming down this way. Over here, it's going to go to the system. This is PP bus A on. It's going to go out to the system to power everything. And then it keeps on coming down here, and it'll go in for just sensing, PP bus sense, so charger PP bus sense. But along here, it's going to go through this resistor. This is the 0.005 ohm current sense resistor. And then it's some 1 ohm resistors. They're just like protection resistors, control resistors, to sense the voltage drop across this 0.005 ohms. And the more current that flows, the more voltage drop you have across this resistor. So then that's how this chip knows how much current is flowing. And if it's a positive voltage or a negative voltage, it knows which direction the current is flowing. So that's what we're looking at. As we're looking at right here on this, and then it's kind of mirrored the same way to the system. And so all of this is fine. These are the two small 1 ohm resistors, and then this is the 0.5 ohm resistor. So you should have a 0.005 ohm resistor. So you should have 2 ohms when you measure across this capacitor. It's the same thing as right here. I could show that. This is the capacitor right here that we're seeing. So you can measure across the capacitor to measure the outgoing and all the way back here. So you just put your multimeter probes across here and you should have 3 ohms. So that checks out. On this board, that checks out. There's nothing wrong with that. So that's a possible failure point for this weird type of failure is current sense. So that's fine. So then the next one is this MOSFET might be bad, or something that controls this MOSFET might be bad. Looked at all of this. You check the controls and everything in here on diode mode. Measure it with one that you know is good on the other donor board. Measure everything for a known good. All the diode mode readings check out. Everything's fine with that. I noticed that the battery connector was a little stretched out, so I crushed it back in and everything. Readjusted all of the little connectors here, all the little contact points, cleaned it all out. There was some dust and stuff in here, some plastic chunks and stuff like that. Cleaned everything out, still not working. So then I come over here to battery communication. So battery communication is a pain in the ass. This, all the MacBooks, pretty much everything today, it doesn't just give battery power. Batteries just don't turn on. You can't take a battery out of a box and just throw a multimeter on the positive and negative connectors and get power out of that. None of these batteries do that. They have built-on battery control boards, battery management systems that will turn off, this one even has a current sense resistor on it, that will turn off the battery until it's told to be turned on. So that's through a couple of different ways that a MacBook will communicate with its battery to tell it to turn on. So the first way is with something called sysdetect. So if we go back over here, let me bring my preview. I want to make sure I'm on the right thing for you guys. Bring my preview onto this monitor so I can actually see it. Okay. Welcome to live. Pretty much all my videos that I ever do have a live feel to it. I never script anything. I might write some of the produced videos, the edited videos that I do. I might write some bullet points of things that I want to take care of, I want to address. But most of the time, everything that I do is just live, off the cuff, just explaining what I see, what I know, what I can convey in it. I've never written a script. I probably should try that sometime. But let's take a look at this. This is the battery connector, and you see that this is all grounds. Even the red one, which is it's red because it's pin 1, but it's still ground. So this whole side is ground, except for this one not connected, and this one is this BMU Detect L. Never saw that before, not sure exactly what that is, but I'm going to go after the one that I know right away, Sys Detect L. So if we look at Sys Detect L, this has been on MacBooks for a long time now. Sys Detect L is basically for the battery to detect that a system is connected to it. So usually Sys Detect L just goes to a resistor that goes to ground. All it needs to do is just see a resistance to ground. You need to pull this line down to ground, and then the battery will turn on. As long as this is ground, then the battery senses that it's connected to a system, and it'll start powering the main power, the ground and the PBVBAT. So this is a little different. We've gotten much more complicated now. Let me bring this up on the schematic. So BMU SysDetect circuit. So I guess that's battery management unit, system detect circuit. This is not on the battery management unit. This is on the system. So what we're looking at here is a 2.49 kilo ohm resistor that goes to. It has a diode to ground, probably some kind of ESD detection or something like that. And then we have a 0 ohm. Hey, Mr. Daniels. Just talking about you and your wonderful software that you're going to yell at me because I did not update it. So this is the SysDetect. We go to a 0 ohm, and now we go to a MOSFET. So now we've gotten really complicated. So SysDetect only used to be a resistor that goes to ground. That's it. There would be ground on the other side of here. This would go to the battery, and it would just see ground, done, battery's on. Now we have something else that's controlling SysDetect. So I'm looking at this. This seems to be fine. It seems to be fine with SysDetect. But I'm still not getting any battery power. The battery's still not turning on. Battery's still not activating. Like, what the hell is going on here? So then I start looking into, well, what is this? Why is this here? What does this have to do with everything? And I find these right here. So we have this BMU control, detect, and BMU stuff over here. So this comes down to this one. This resistor here, BMU control, detect, L. So come over here to the battery connector. That's this one here. So in the connector, I saw that the corner was a little bit chipped away, and it just didn't look exactly great. So I smushed the connector around. I made sure that it was connecting and all that. Still not the problem. Still not connecting or whatever. So I start, last-ditch effort, I start diode moding. Usually you can figure things out before you have to start doing this, but this is when, like, things just aren't working, and now we need to start looking at why the hell this crap isn't working. So we go back to the schematic here. All of this stuff has to do with the communication. Everything here in this corner has to do with the battery communication. So the basic communication was SysDetect. And then we have the normal SMBAT, SDA, SCL lines. So these all come down to here. They go to a normal big diode, and they go to their resistors and stuff. They're pulled up by 1.8 S2. So I start checking all this. I do have my 1.8 S2. When a battery is not connected, it's still 1.8S2 over here, so that means these are just fine. When you connect the battery, these go down to 0.6 volts. So that's what you should see. The 1.8 volts on this side is 0.6 volts. That means the battery is pulling things down on the data lines, and it is actually communicating. So you should not see when the battery's connected. If you see the full 1.8 volts on the other side of here, then you know something is bad on the battery communication. It's not actually doing any communication. So you don't have to like logic probe it or put an oscilloscope on it, as long for now anyway. But as long as you see 0.6 volts, something or something around there, it get pulled down, then you know it's communicating. You don't know what it's sending, but you know it's trying to communicate. If you need to know what it's sending, then you would actually have to put an oscilloscope on here and try to read things. So it goes through here, and it's just communicating to the ISL. The ISL seems fine. There's nothing wrong with the ISL from previous testing, so there's nothing going on there. So diode moding all this stuff, everything seems fine, diode moding everything. And then I get to the sysdetect. Sysdetect is fine, diode moding, and then I get to this new sysdetect, this BMU control detect, whatever this is. And I notice there's a discrepancy between the donor board that I have and the board that I'm working on. So at first, I didn't notice this other line going down that way. So I just saw that it was going to the battery connector. So I ohm checked the battery connector to this, and everything's fine. I'm like, why is this different? It's only going one place. Wait, it's not going one place. I zoom out, going all the way down here. What the is this? Why is this over here? Well, guess what? Here's our sysdetect. Here's our BMU sysdetect thing going on here. And let's travel all the way down, all the way down. Oh, look at all this stuff we have to go by. All of this stuff, all these big chips, all this stuff. What the fuck is that? Who the fuck are you? I don't know why it's there. There's a clue as to why that's there. Why is it so far away from everything? I'm working on the battery. Battery's all the way up there. Why am I looking down here? Battery is all the way up here. All the way up here. All the way up here. Why am I all the way down here? That's that far away from one another. Why am I all the way down here? What? Why are you going to route all of that through everything? So there is a clue in the schematic. Is this the right page? This is the right page. I've never seen this before. I'm not sure what this is. BMU sysdetect notes. Never dealt with this before, but BMU sysdetect circuit relies on assembly in order to be properly enabled. So, from what I gather of this, is that this resistor is actually not supposed to be there. It is there on every other board. It's not supposed to be there, and it's supposed to short out something when you put the heatsink thing back on there. It's supposed to short something out and connect everything back together. I think they abandoned that idea, and they just left the resistor that they talk about next in here. So during assembly, a metal gasket is placed between the cowling and the top side of the BMU flex. The gasket is used to connect BMU to ground. Once BMU sysdetect circuit is ready to be enabled. So since that resistor is missing, it's actually like all of this. I can't highlight all of this being missing, and it's not letting the battery run. So the BMU VBAT output will be enabled after the BMU flex and kind of blah, 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 blah. And then if we come down here, in the event that the cowling needs to be removed while retaining power to the main logic board, resistor R51B1 can be loaded. R51B1 is always loaded. It is, there's no notes. God knows what schematic revision we got. But there's no notes that it should be loaded. It all is loaded. On all of the other boards that I have here, it has that resistor there. This one got knocked off by somebody fat fingering or fat fingernailing the webcam connector off of there. So one little resistor all the way on the other side of the board is what's keeping this battery from charging. This, yeah. That would be a hell of a, as Paul Daniel says, oh, that would be a hell of a nasty trick for them to pull if they were relying on the shield to complete the circuit. That's what it sounds like. I'm not sure exactly what they're talking about with the gasket is used to connect BMU control detect signal located between two ground. So they think that this thing was going to connect something to ground to enable the battery. So the battery, this thing would, the logic board would only work off a battery if this shield, which I guess they're calling a cowling, was connected. And as soon as you pull this off, no battery working. If that was the case, then we would have definitely known that. We would have seen, somebody would have seen this by now and knew that when you have your logic board on the desk, it's not powering up. Somebody would have found this earlier. This is ridiculous. I wouldn't call it, somebody's wrote a nice anti-repair trick. I don't know if I would call it an anti-repair trick. I don't know what they were thinking. Why? Because if you want to say, okay, if you need to troubleshoot this board, you need to populate this resistor on the board. Why is it all the way across the board? So this is kind of an anti-repair trick, because if I didn't have my schematics, if I didn't have a board view, if I didn't have schematics, if I didn't have Paul Daniel's software to read them, then I wouldn't know where to look for this. I wouldn't know that I have to go all the way across the board between the webcam and the screen connectors for the battery. That's all the way across the other side of the board. Everything with the battery is all contained right here. There's the ISL, there's the battery MOSFET, there's the communications, there's the connector. And then all the way over here. This is screen. This is webcam and screen. This is the stuff that goes out to the screen. Why is there a little resistor right there? So, you get to see the fix. I have not fixed this yet. I have not tried to fix this yet. I worked on this for a little while, trying to figure out, like I said, I started diode moding every single little piece on here to see and I'm going back and forth between my known good working board. What was that? I don't know what that was. My known good working board and my dead board here. And then finally, I find this. The little corners of the pads are bent up a little bit. So first thing we have to do is smooth this over. Now it's nice and flat. And this is a 201 0 ohm resistor. So let me go over and get my handy dandy 201 resistor book. And does this have 0 ohms? Yes, this has 0 ohms. 0 ohms you go through a lot. So, always great to have these books laying around. Need them for stuff like this. I could take the one off of my working board, but I want my working board to remain my working board, even though I already harvested a CD3217 B13. Yeah, but I have a new one to put back on there. I just needed it in the moment. But let's grab a 0 ohm. Oh, no, it's too short. It just fell in on me. Okay. That's what she said. We got a 0 ohm resistor. Tiny 201. So our fault lies with this piece. It's at the end of my tweezers there. It's between my tweezers. That piece. You'll see it in you kind of get to see it. I don't know how well that comes out. You probably can't see anything. I'm a little zoomed out. But let's see what it looks like in the microscope. Sometimes people don't realize how small the stuff is that we deal with. That is what I need to replace there. So I'll get some fume extraction. Let me put this off to the side for now. I don't want to use hot air on this because it's right next to that connector, and that connector is in good condition. So I'll just put a tiny bit of flux right there. It's actually kind of a lot of flux for me. And we'll put some fresh solder on one of these pads. Okay. Then we'll take our resistor, put it down on the solder. Excuse me. Now for comfort, I am going to move the board a little bit so that I can hold this straight while I solder it. And that's that's definitely not straight. Okay. Flatter. And yeah, I'm trying to be perfect, and you always mess up when you try to be perfect. Okay. Good enough. So now we'll flip it around the other way so I can touch the other side with the soldering iron. I guess that's the ground side because that's not taking heat very easily. But I think we have good penetration there. Okay. I'll do a little bit of Q-tipping. Okay, that's the repair of one ripped off resistor. Now, let's see if it worked for our purposes. Why use a 0 ohm and not a jumper wire? A couple reasons. A 0 ohm resistor is kind of half-ass a fuse. They will burn out, unlike a jumper wire, if they need to. Then they populate on there properly. A jumper wire would possibly slide around. It wouldn't be, you know, a nice square little box that fits on pads. In the factory anyway, they would never use a jumper wire on something like that because you can't have a system automatically place a tiny jumper wire like that. I could put a jumper wire there, but me personally, I would never put a jumper wire where a 0 ohm resistor is supposed to be. Like, yeah, I might do it for testing. If I have a burnt out 0 ohm resistor, I might put a jumper wire right over top of it, but I'm never leaving it like that. It's never going back to the customer like that. That's just unprofessional. All right, moment of truth. I have some charge ports connected. I have a battery connected. Now first, let's see what PP bus measures right away. It should not be connected, because I think these batteries do not connect until they're told to connect from the PMIC or the CPU or something. So let's see what PP bus is. Nothing, 0. Okay, let's connect our power. PP bus is 12.2, 12.7, and we have a chime. 12.6 volts on PP bus. Let's try disconnecting the power. 12.6 volts. Power's right there. .6 volts. So that was it. That trolled me for a bit. I did not think to look across the board at all. Why would I think to look across the board? But let's disconnect this. I don't have any heat spreader on or anything, so. So one tiny resistor in a weird place that good luck if you find it. So this is just another thing. So I also see that there's a tag on the screen cable. So I guess this got a new screen. Somebody changed the screen, and they knocked off that resistor. And yeah, you see where it is. I can kind of see it through here. That's it. So I can definitely see how somebody would put their fingernail or put a pair of tweezers along the side here to pop the webcam connector off and hit that and take that off instead, or with it. So that is controlling all of this. It goes directly to that one. So definitely something to keep in mind when troubleshooting these. If you have battery issues and everything looks fine on the battery, and especially, ever since I changed my screen, the battery doesn't charge anymore and it doesn't run off a battery. There you go. I haven't heard this one yet. I'm sure somebody has a video of this. Somebody has. Paul Daniels, you ran across this yet? No, I seem to be getting a lot of these. Like my last 2 or 3 streams, like, yeah, I have a framework stream, but the last couple of streams was this board. I'm getting to know this board really well. Hey, Daniel. So, yeah, thanks for tuning in. I'll look through chat, see if I missed anything. On a scale from 1 to 10, that is a clear FU to repair people. What reason would there be to place it there? That's what I really want to know. So when I first saw this, and I'm like, I have to make a video. I have to go live. I have to tell people about this. People must know. Shout it from the rooftops. Why are you routing this line all the way over there? Is it for, well, okay. So it's for, supposedly it's not supposed to be there. By the notes, that resistor is not supposed to be there. And if you need to troubleshoot the board with the cowling off, then you put a resistor there. You put a 0 ohm resistor there to power the board with it open for troubleshooting. That's the only reason it's there, is for troubleshooting purposes. So where are we going to put it? It needs to be outside of the cowling. I don't know if my overhead camera is actually going to be good enough for this. Let's try. Crotch shot. Jeez. Yeah, I don't have such a great overhead camera. Let's see. Yeah, there we go. Okay. Okay, so we need to put it outside of the cowling. And basically, this maybe it's not an FU. Maybe it's the exact opposite. Because we don't want it near... This is outside the cowling, right in here. But you have the battery connector covers all of that. You can't see anything when the battery's connected. The cowling goes all around here. So we have some space right here. There's a little bit of space right here by the DC in... Am I back? I left my my D850 on battery instead of on power adapter. So that just cut on me. So yeah, they want it to be outside the cowling. Here's the cowling. So the cowling's going to cover everything, pretty much. You have some space over here by the Wi-Fi connectors, but I don't want to run anything near Wi-Fi. This connector's too much in the space, takes up all the space. This is all covered. Like you think you might have space around here, but that's actually covered by the cowling. So this little tang here where the screen connectors are is the only thing that's not covered by the cowling, really. Or at least it's the thing that's not covered by the cowling that's closest to the battery, I guess. Closer than here. It's closer than here, so it's right here. Because it goes to this pin right here on the bottom of the connector on this side. So if you're working on it and you don't want to take the cowling off and you need it to power up but wait. If I didn't take the cowling off, then I would have power. So you can put this anywhere. You can put it right over here because I need to, once I take the cowling off, is when I need to populate the resistor. What the fuck? It doesn't need to be outside of the cowling because it supposedly if the cowling is on, then the battery's going to work. As soon as you take the cowling off, the battery won't work until you populate that resistor, which they abandoned that idea. So that's not how it actually works. They abandoned that idea, but they still left the remnants of that engineering on the board. But if you're taking the cowling off, then you can put that resistor anywhere the hell you want in a nice open area, such as nice big open area such as this right here, right near the board number, near all of the other communication stuff. This is all the other communication stuff. The SDA, SCL lines, the pull-up resistors, everything's here. So they could have put it right here, away from everything over there and where nothing is heat bothered or anything, and you could just put a resistor right there. But no, they put it here, all the way across the board, next to something that would be heat bothered by trying to solder with hot air next to this connector. That would be heat bothered. And it's right there where it can be picked off easily. Like, it doesn't have to be outside the cowling because we're already inside the cowling if that's what we have to do. And then the wire is run under, like, near the CPU, near the Wi-Fi chip, near the PMIC. It has to snake through all of this stuff to get all the way back up here and connect to this pin here and this resistor right here. I don't know. I don't know. I don't know. I don't know. Why? I don't know. No, I'm not taking this out. This is supposed to be there. So TJ. So this idea was abandoned by Apple, but this still has the remnants of it in here. This resistor was plucked off by somebody with a long fingernail taking the screen off. And yeah, that's why the battery wasn't charging. But now this is something you got to put into your memory about this now. Resistor books trigger Paul Daniels? Why? I love resistor books. I have all of them. Yes, never update software. 100% guaranteed to break something. As Paul Daniels is probably mad at me and probably left because I am using old software. But I tell you what, Paul, if you're still here, Mr. Daniels, I haven't updated my updated software, but I have the new software on my other computer, and it has a weird bug that's been annoying me, where every time I go to open up a new schematic, it doesn't open up my schematics folder. It just goes straight to the documents folder. Am I doing something wrong? Did I have to check a checkbox to keep opening the same directory that I have everything in, rather than going to my documents directory every time I open it? I don't know. Let me know. I haven't looked into it. I could see that. The Paul Daniels doesn't like resistor books because they're the lowest of the low resistors. They're the cheap junk. I haven't had any problems with them. The ones that I've used, I used to test them. When I used to put them in service, I used to test them to make sure that they were within tolerance and everything. And the books that I have anyway, I've never had one fall out of tolerance. I don't know. I don't think these are reputable. They weren't cheap though. I didn't pay, $10 for these. These were like $30, $40 books, each one of them. They are just straight from China, from AliExpress, but I didn't buy the cheapest of the cheap books. I did buy the middle ones. I didn't buy those really expensive ones, but I didn't buy the really cheap ones. And then the really popular ones, at Rossmann Group, we used to change them out. Order like Zero Ohm is one of them. I forget all the ones we did, but we ordered spools of 1,000 or like 5,000 or something like that of like the popular ones that kept on going out. 10K. 10K is empty in this one. I think I have a spool of 10K over there. I got to cut a 6-inch section to put in here. I've never seen Farnell or Mauser or DigiKey have these books. Maybe I have seen them on DigiKey. Possibly. There's a couple vendors on Amazon that sell them. They're pretty expensive. $800 on Mauser. Jesus Christ. Yeah, I'm not spending $800 on some resistors. And that's why, yeah, it really is better to have donor boards. But all of these new machines, everybody wants astronomical prices for dead boards. Even this iCloud locked board, because it was working, they want more money. Since I know everything's working on the board, it's just iCloud locked. I forget what, probably like $200 for this stupid board. But it's worth it when I need to diode mode something, or I need to check something against something that's not working. It's invaluable for that. You need it for that. Well, thanks for joining me, guys. Good to see everybody here. I haven't been around in a while. I always say I'm going to try to stream more. I do have some interesting videos that I've recorded that I need to just edit up and put out there. There's one that I'm probably just going to have to redo the audio because I was so salty through the whole entire thing, doing a charge port on a dental instrument, where there are a couple people that have worked on these dental instruments before, and all of them have hidden the parts from us. They won't just tell you, oh, it's a 8-pin USB mini. Just tell me it's an 8-pin USB mini. You're going to tell me that you went to you found the actual Chinese manufacturer and that they sold you new charge ports. Come off it, dude. They're trying to hide the parts so that people have to go to you for the repair because nobody else is going to find these parts. Please. Just thinking about it, just even explaining it, I'm getting salty about it. It just pissed me off. Like, you're another repair shop. You can just tell people what the repair is. You're on YouTube. You're making YouTube content. You know, whatever. Fix a skateboard or something now. Fix a skateboard. Fix a skateboard. PS Consulting. That little thumbnail looks familiar. That could be a friend from high school, I think. Where did I disappear to? Busy. Hello, KC. Initials. Nice. Fix anything. Fix a skateboard. I don't have a skateboard to fix. What do I have to fix? You want another fix? I got another fix. I got something somewhat simple. You can clean up the 2681. What do I have here? This is a 2179 MacBook Air. I'll leave the casing over here. Okay, hi everybody. Today we have a 2179 MacBook Air logic board on the desk. Let's get that schematic up. So this one here does not turn on. We have no power. This is board number 820-01958. It's a MacBook Air from 2018, 2019, somewhere around there. And if we plug it into the charger, what do we get? I have 5 volts, 30 milliamps. And that is it. 5 volts, 30 milliamps. Does anybody tell me what is the first thing you check on a MacBook logic board? What is the first power rail that I'm going to go after? Now, it could be named a little different on this newer one. I'm not sure what year they changed that. PB Bus. All right. Tech 49. Winner, chicken dinner. Okay, PP Bus. Is this PP Bus on this board, or is it called... Well, yeah, it is PP Bus. It's either PP Bus G3 Hot or PP Bus Aeon. What is this one? PP Bus G3 Hot. This is old enough that it is PP Bus G3 Hot. Let's look at our board view here. I know where to go for it right away, but if you don't, we're just going to search... PP Bus G3 Hot. And we'll search for that. And I have a call very well after hours. It is 8:45 p.m. Eastern Daylight Time. Welcome to Daylight Time. And somebody is calling my business. They hung up before even voicemail would pick up. We are open Monday through Friday from 10 a.m. till 6 p.m. Feel free to call back during that. Okay, PP Bus G3 Hot. So I always go up over here. This is a nice big 0 ohm resistor fuse type thing. So you know it's a 0 ohm because it says 0. Try to get the same view as what you see on the board view. Exactly what you see on the board view. The current sense resistor, the whole current sense circuit has been abandoned, so there is no current sense at that location anyway. So black probe on ground, red probe on PP bus, and we have 0. There is absolute 0. We still are 20 volts with 30 milliamps on the charger, but we have a 0 on our PP bus. So what is the most likely cause of 0 on our PP bus? Anybody? Come on, somebody got to know it. Aeon is the M series. Okay, so that's the differentiator. So as soon as we went to M CPUs, it went from G3 hot to Aeon. That's good. Never fully picked up on when it changed from G3 hot to Aeon. So short. We got a short on PP bus. We'll change over to ohms mode. Put the black probe on a ground point. This nice little lug here. You guys can't see that. This nice little screw hole here is a great ground point. And we'll go over here. And what do we got? Wow, 0. Direct short. Full on short. So what's the easiest way to find a short? I know me and Lewis kind of disagree on this. He loves using his alcohol pouring all over the board. I don't like the way the board looks after pouring alcohol all over it. I don't like the way the board looks after pouring alcohol all over it, so yeah, I'm not going to do that. I have a thermal camera, which is not within my reach. I will have to get that after I set this up. So first thing you have to do, find a good, strong point to solder to. You want to find a large capacitor or something. So we're going to go back to the board view. And now everything in green is PP bus. That's us highlighted PP bus. These two are some giant capacitors. That wouldn't be bad. But there's a bunch of stuff really close to them. I don't like that because this is not, yeah, NAND SSD 0. I don't want to be injecting voltage anywhere near this crap. PPVC NAND. If that's the 2.5 volt NAND phase. If it's the 12 volt, no, that is the 2.5 volt for NAND. You do not want to be soldering anything over here because if you accidentally put a little hair over to one of these, you just killed the person's data. You put 12 volts to those NANDs, you are done. So we are not going to be soldering here. This is a nice big capacitor, and all it has is the, what connector is this? This is speaker. A speaker connector, and yeah, nothing else by it. Nice big opening. It's a nice big capacitor. That's a perfect spot to solder our injection wires to. So let's see what that looks like. So that's what we're looking at. The speaker connector and this nice big capacitor right here. So this is a perfect spot to solder our voltage injection wires to. Let's pull out some wires. So I have this one that goes down to a nice thin one, and we will solder that right there. So first, we'll prep it. Let's get it facing the right way so it's easy to do. Get a little bit of flux on that. Some fume extraction. Okay, we're going to add a little bit of fresh solder to this joint right here. Get it to flow nice. And we'll take our voltage injection wire. Solder that right there. Okay. Now a good ground point. So I don't think the fiducial is a ground point. I don't think it's actually grounded. This is just for the camera that's placing all of these things to make sure that it's aligned properly. It has a couple of these fiducials around. That's not going to be a good solder point. This, I don't like how things... I want something on the edge. I want something away from everything. I don't like screw holes. Other side of the board? Yeah, no, I don't like these test points really there. Geez, there's not a real good ground spot. I don't want to be anywhere near the NAND. This wouldn't be bad. Let's see. I guess I could go this way. Yeah, that's not bad. Just solder it right here. Tug on it a little bit, make sure it's connected. There we go. Now we have our positive and negative on here. Let me go get my thermal camera. So I have the Seek Thermal Compact Pro with the macro lens for when you need it. It's been absolutely amazing. Absolutely love this thing. It's not the greatest connection that you have to use a device and all that. That's not ideal, but man, this thing is good. Okay, I will start recording this so that in the edited version, I will have a video to put somewhere over here. The only thing I don't like is on its warm-up, it's constantly flickering like that. So, focus a little bit. Okay, there is our board. Okay, let's, oh, I did not configure the, turn off the output. Okay, turn on the power supply. Recall 3, enter. That's 1 volt at up to 10 amps. Turn on the power to the board. And something clicked, and it immediately went to 0. Do I have any latent heat? Something clicked on the board, and it immediately went to 0. So what you're seeing hot there, those are reflections, a lot of reflections. You have to try to get around those. So this may have been just some capacitor somewhere. We may have actually burnt out the short with 1 volt. Let's make sure we have 1 volt on the board here. PB bus is not 1 volt. I probably have the wrong thing plugged in. Let's see. I do. Okay, never mind. I have the wrong leads plugged in. Technical difficulties, please stand by. As we get live streams that I didn't even set up for. Okay. I think those are the correct. That should be correct. Okay. Let's try this again. And we are at 1 volt at 1.3 amps. 1 volt at 1.3 amps. We should be able to see that. So I have a hotspot right here. It's on the other side of the board, though, because it's spreading. It's a spreading hotspot. So we'll flip the board over and look at that. Would you look at that? That is one bad capacitor. So it's kind of hard to see which one it is from this video. So you wind up putting either your finger in, which my hands are not that cold, but my finger is a lot colder than that that capacitor. So it is this one right here. Yep, that's it right there. All right. So one shorted capacitor. Let's turn off the power. I know what capacitor it is. I'm just going to put a scratch in it so that I definitely know. We'll take our lines off of here while we're working. Okay, let's go get a stack of donor boards for this. There it is. Let's take this one off first, and we'll see if the short is gone. It's always a capacitor. That is why the big electronics forum is called Bad Caps. A little bit of flux just to get around there. Some hot air. My hot air is always set at maximum and maximum. So this is set at 95% air and 450 degrees C. Look at that, it's bubbling up. You probably can't see that because you through the one lens to the camera, you don't have a depth perception, but this right here in the middle is bubbling up right away. You can probably see that it's squishy. It cracked. So that bubbling up like that shows to me that that's what it is. It's definitely dead. And now we'll check with our multimeter across it. Back to ohms mode. There you go, some odd K, some odd meg. Yep. That's it, that's good. That was the dead one, so now we'll replace it. First I'm going to come in and clean up these pads a little bit, just wet them with some leaded solder, just so that it'll flow back in easier than what it came out. And then we'll go on the donor board. Donor board already is flooded in flux. Looks like Lewis may have touched this board. I think I heated that one too fast, and it just cracked on me. Something just cracked. Is that a crack down it? I might have to take this off from underneath. It's not a crack, it was a piece of dust. they identical? Let's see if the two on either side of one another are identical. So where are we working on? We are working on these two dudes. Yep, these two dudes. Let's see what this one is. 33 microfarad, 16 volts. What is this one? 33 microfarad at 16 volts. Okay, they're identical. So I could take either one of them. There's nothing good on the other side. Let's actually make it easier to get these off. I'm going to go after this one, the second one. I'll put some flux on either corner there and just fill in with some leaded solder, make it melt quicker. I'm also going to come in at it a lot slower, so I'm going to start... I already had the hot air pretty hot. It's already lifting from that one side, just this. So, it should come off pretty easy now. I'm going to come in with the hot air cold and go right onto it. Try to heat the board around it more than the capacitor itself. There we go. I'll let it cool down a little bit. I will test it to make sure it's not short or anything. And it is open line, so it is not shorted. Just for the hell of it, let me see if it's cool enough. Yeah, it's cool enough. Let's test the capacitance of it and see if it's the proper capacitance. Ooh. No, that's even better. It says 38 microfarads. What it's supposed to be? 33. That's perfect. Well within tolerance. Okay. Yeah, since these don't like hot air, let's go ahead and do this with a soldering iron. First, let's clean up the pads. That is a terrible end of wick. Man, this is a terrible wick. Let's use some actual goot wick. Let's use some actual goot wick that doesn't have a bunch of solder in it already. Now, if you notice the difference between that was some just generic nasty wick, and this is actual goot wick. I need more flux on the wick. There you go, nice and clean. And we'll add some fresh solder to the one closest to us. There you go. I'll put the capacitor down. This is the right one, right? I have two sitting here. One's the dead one. Which one's the dead one? That's the dead one. I put a scratch in it. Okay, there we go. Let's make sure everything is not shorted. Go back to ohms. Good, not shorted. We'll do some Q-tipping while I read some chat. We just see the board view. Did I leave the board view on the entire time that I did that? That's absolutely wonderful. That's absolutely wonderful. There it is. As you get with live repairs. There you go. You guys didn't get to see it get put on. Just imagine the wonderful job of soldering that you guys missed. All right. Little blast of air. Dry everything out. Donor board. Okay. Oh, I need to Q-tip up the where we injected voltage. That looks good. Charge port. Lead to 96 watt Apple charger. Plug in. 5 volts. 20 volts. 100 milliamps. 60 milliamps. 70 milliamps. 130 milliamps. 190 milliamps, 200 milliamps. That is turning on. 700 milliamps. Yep. This is booting. There you go. One excited customer. This customer was excited just with the prospect that their board would be fixable. They are going to be ecstatic to know that their board was fixed. Mail in from some part of the country. So yeah, if you have anything that needs repaired, any MacBooks that need repaired, you can mail in, bring it in. You could go to sendmeyourmacbook.com for information, or links in the description below and all that. Fanspin. I wish we still had Fanspin. I miss Fanspin. Paul Daniel still here? There's no Paul Daniel still here. I'm not sure what the typical turnaround time is out in Australia. Wrong Paul. So for me, it all depends. I'm the only one here. Well, like a bunch of other people too. I'm the only one here. Things get busy, things get slow. If it's slow, it's a pretty quick turnaround. Things are kind of busy right now. This one was not going to get repaired because it's after hours. I'm closed right now. This one was not going to get repaired until tomorrow, but this one showed up today. And you saw me repair it now. So that'll get reassembled and be ready for payment and shipping back tomorrow. The other one got here last week, Friday. The other one that I repaired. It's repaired today. It all depends on the problem, though. See, I have some that have been here for a couple weeks now. Like this one's a thorn in my side right here. It all depends on the issue. These were simple issues. They were simple to find, simple to fix. That issue right there, I think I need a PMIC. I can't prove that it's a PMIC, so I don't want to change a PMIC until I can prove that it's the PMIC, because that's like kind of an iffy repair to do. It's right next to the T2 chip. It could go wrong very fast and be a total nightmare. So some repairs, I don't like letting go of a repair. That's my problem, is that if I can't prove what's wrong with it, if I can't prove this is what is dead and I cannot fix it, then I just keep going at it. I keep wanting to figure it out. I keep wanting to go at it. And I will spend hours and hours and hours on a board until somebody finally tells me, like, look, I'm done waiting, or something like that. And hopefully it's before somebody gets angry that their machine took too long. But know that if it's taking a while and your machine's here, I'm working on it. I'm trying. It's just I can't figure it out, and I don't want to let it go until I figure it out. It's probably a bad thing for me, is that if I don't find a reason, like, hey, the CPU is blown out, and once I find that, like, oh, that's easy. I know what's wrong. I know it's dead, and there's nothing I can do about it. If it's I can't figure it out yet, or it keeps giving me little glimmers of hope that it's going to work again and it's still not working, I just won't let it go. I will figure it out eventually, but it might take a while until I'll finally decide, no, I can't work on this anymore. But yeah, usually a couple days to a week for most things. Some things like that, yeah. If I can't figure it out, I don't think anybody else can figure it out. But, you know, yeah, if I'm taking a while, you can more than welcome to have it back and bring it somewhere else. But if I can't figure it out, I'd like to see somebody else do it. And if they do, I want to know what the hell happened. We got a 2159 here for over a year now. I've been going back and forth on it. Short of PP5VS5 rail. Taking everything. You know what? I have a what is it? This is another one that's been bothering me a lot. As PP3V3S5 is missing, and the board is in recovery, and it's in recovery because the PP3V3S5 is missing, and I can't prove why 3V3S5 is missing. 3V3S5 should never be missing. And what is this? 1989. I'm not sure exactly why 3V3S5 is missing. All the S5 rails should be there right away. That one's bothering me. That one's really bothering me. I've spent a lot of time on that. Usually it's after hours is when I'm working on these things, because when you're working on a complex problem and you start building the schematic in your head and you're building up everything, you have to answer the phone rings, you have to go answer the phone, all of that comes crashing down. And when you sit back down in front of it, you have to just start all over again with, okay, where was I? I was looking at this connects to that, and you're building the schematic in your head again and building the flow of everything in your head again, and then somebody walks in and crash down to nothing. And so that most of the time when it's hard problems like that, I'll wait till after I close and I can just turn everything off and just work on it. And yeah, I've been down here till wee hours of the morning working on things. Probably busy wrangling the cats. I only have one cat. So I basically stole a cat off the street. We have a couple strays around here, and this one stray I've been feeding in the backyard for about a year now, and she's a little sweetheart, and she was skittish. She wouldn't really come up to me in the backyard, but she would always, like, let me sit near her and talk to her, and she would eat and then just sit there and loaf next to the dish and just listen to me talk. She seemed like a real sweetheart. And finally in December, it was just way too cold out. So I coaxed her in the door, and she hasn't left since. She's our cat now. We took her to the vet. We had her dewormed and all the parasites. She's still on antibiotics and stuff. But yeah, she's really happy. She's really sweet. So I do have one cat now. I'm happy to have one cat. Could be worse. I tried to record a video yesterday and found out I forgot to hit the record button. I've done that. Yeah, I've done that. I think it was my Ryobi video. I did that. Like the whole opening I had to do over again because I forgot to hit record. I sounded great and everything, and I had to do it again. So that's my 2 repairs for the day. Nice to see everybody. Glad you could all join in. How many people watching anyway? I haven't had the YouTube studio up. All right, 25 people here. Nice to see you guys. Good evening. Thank you for watching my videos. Everybody have a good week. Happy Monday. Happy Mario Day. If anybody is a fan of Super Mario, happy Super Mario Day. It's me, Mario. But yeah, enjoy the night. It's getting late here. 9 o'clock. Have a good one.